All right, so this is a continuation of our embedded track. It's the first time we've had an embedded track here at Scale, and Stephanie is going to do a presentation here. She's a consultant with VCT group, and she's been here trolling the rest of the presentations all day, so save your trolling to the end here.
You don't have to save it to the end. It's okay. I'm used to it. So, is it time to start according to schedule? Okay, I'll move right past my title screen rather quickly then, because usually it serves the vital purpose of letting people know that they're in the right room, but I'm going to assume that since all you guys have been in embedded talks most of the day, that you probably mean to be here. So instead we have this little playing with fonts, which was this was my first presentation done with Inkscape, so I couldn't resist. And I do indeed work for VCT Labs, the same company as the Yocto guys who came up a little earlier. So I'm going to start my talk on USB with an overview. It's got to be a little basic for some of you guys, but I actually think that some of this stuff is mnemonic for being able to interpret the traces when you get down. I'm going to avoid all the little details like what resistors you need for the different speeds and so forth, and just go with high level. So USB as a bus is one of those point-to-point buses. It is not like PCI, the fancy stuff where you can have these smart targets that talk to each other and push data back and forth. No, the host in this case is the central point. The host is in control of the whole bus, and it's a star shape. I didn't draw it, but you can also have USB hubs that have more little dangly targets on the ends, but everything goes back to the host. So basically the USB host is in control like an authoritarian dictator. Nothing happens without the host allowing it to happen. There's just a tiny little caveat. If people are thinking OTG right now, just later. Okay, so we have our authoritarian host that is completely in control of the bus. Well, we know who's really the power behind the throne, right? That's the user. They're telling the host what it's supposed to do with the software, and then the USB targets get to be the little minions that just do what they're told. So let's suppose you have a USB host that's talking to a bunch of typical devices, say a scanner, a mouse, keyboard, printer. As a user, you may feel like you're in control with your mouse and your keyboard, but if you look at it from the low-level perspective, you are not. You are just acting as a shadow minion who is giving these little instructions out of band to kind of prompt the mouse and the keyboard what they should say next time the USB host gets around to asking it to report. So at all times, the USB host is in control. So when you're a new device on the bus, the USB host is responsible for doing the roll call, aka the enumeration phase. There's no way that the target can make the USB host recognize it. And the USB host is going to go through and give every target its turn. And if the target wants more of the bandwidth, that's just tough because it gets the amount of bandwidth that the host provides to it. So in this host-centric world, one of the reasons why I emphasize this is because when you're looking at your traces, the directions are always going to be from the host perspective. So you see something was an out. You have out data. It's never the keyboard sending data out to the host. It's always the host sending a command out to the target. So if you're looking at things from a target perspective, try not to. Think of it as from the host perspective. If you're doing an input, it's always an input to the host. You're not reading from your target. You're going to be writing on the in cycles. So now let's take another, again, a pretty high-level overview. We're not getting down to the real bits running on the bus here. But how does USB do its addressing? Let's say you have some generic USB target. When the USB host does its enumeration, the USB host is going to assign your target a device number that lasts only as long as you're attached to that bus. If you happen to get disconnected for a moment and reconnected, your number is gone and you have to adapt to the new one that the host has assigned you as a target. Inside your device, you're going to have multiple interfaces, and these are kind of logical groupings of the data pipes that are going to and from your device. Like if you have a multifunction device that can do, say one of those old ones that did modems and Ethernet, you would have different interfaces. These are the ones for talking to the Ethernet part, and these are the ones that are talking to the modem part. You might have something that's got video and audio, and they'll have different interfaces. But of a special interest, actually, is the setup one, because everybody has to have an interface that you use for that enumeration stage, which is before you have your temporary alias. You have to have a way to talk to the host just to tell it who you are and get the device number assigned. And you have this funny endpoint 0. Every USB target has to have this. And it's a bidirectional endpoint. So it's a bidirectional data pipe, essentially, where both the set of commands from the host and you're reporting your descriptors to say, hey, this is who I am, this is my vendor and my product ID, and you'll give out descriptors to talk about your interfaces and so forth. So the interfaces have different numbers according to what the purpose of the device is. They'll have different endpoints, and some are in and some are out, and the target is it going to read from its out devices or write to it from its? Yeah, it always writes to the end, and that tends to catch people up at first when they're doing the USB. So yeah, you have to, if you're a USB target, you're writing to the end. So here's a little excerpt from an actual device, which is this is the device number that you got when you were plugged in. Don't get too attached to it because it will change as soon as your stick gets plugged and unplugged. It's a new device number. Here you have the endpoints for your storage. It has a bulk type of endpoint for in and another bulk endpoint for out. Basically, read data and you have your read data going here, and your write data will be going there. Okay, so enough of overview, because I presume that's probably a bit of review for most of you who've already been doing embedded. So now let's talk about some of the fun host tricks that you might actually find in the field when you're doing embedded instead of desktop Linux. The first one is nearly universal, and that's that you're going to face limited power for powering up your targets. When you have a desktop, you're probably used to it being able to power up and different sticks, maybe some of those cute little low power USB drives, and powered your mouse, your keyboard, maybe some custom little crazy LED USB device that you've got. That is not likely to happen if you're trying to power stuff off an embedded board. Usually they do not have the power to spare to for a hard drive, for instance, stuff with moving parts. You're likely to be okay if you're just trying to do a mouse and a keyboard, say on your Beaglebone or your Raspberry Pi, certainly. They tend to be okay with that, but you really got to watch it. And that's actually by design, because people don't want, yes.
Well, I have that experience with the Raspberry Pi, but there are some boards like the Voodoo that come with like a 7 to 14 volt power brick, and it pushes 3 amps or something. Should you be able to power a couple USB devices?
That was me saying nearly universal. That's an exception, and it's not.
So that's not a normal.
It's not a normal embedded. What I think of as normal embedded. That's one of the beefy embedded platforms. Also, that other one, that Odroid that you like, is on the beefy side. So is the Minnow board. Those Minnow board Maxes they're strong. You know, they actually can.
Like a 5 amp brick or something?
Yeah, I don't know, but these are more the exceptions than the rule. At least you should check it out and make sure that your host is going to provide the, because it's actually in spec that the embedded boards do not have to provide the 500 milliamps that a desktop does.
Do they not meet that standard?
Yes, they have their own standard.
Well, your desktop should be able to provide at least 500 milliamps
Yes.
per port. That's the minimum. Or you can go a little bit more on a desktop.
Yeah. Mhm.
But I guess that doesn't apply.
It doesn't apply to embedded. So.
That self-powered USB device.
And this one is actually more. This is not nearly as universal, even as the one that wasn't universal last time. This one is just something to watch for, because some devices have these little cut-down controllers that do not support hubs. Hubs is actually a separate little protocol in itself from between the host controller and the hub to diddle with the different ports on the hub and do this. And that's one of the corners that gets cut sometimes in embedded. If you think you're going to use a hub, you better test to make sure your device really talks okay to hubs.
There's also kernel options like creating a disable hub.
Yeah, but I don't consider that a real danger, because you can always turn it back on. But if your hardware doesn't do it, then you might be in some trouble. This is another one that I found that is major, major pain. On a desktop, you would probably, throw it out if you found that your mouse plugins were interfering with your writing to your USB storage. But like, what were these stupid manufacturers thinking? But again, the very cut down USB chips can have a problem when you're doing the old USB 1 and the USB 2 devices at the same time. So if you plan to do it, just beware. Yeah, that's the next slide. You can also have transfer speed issues. Your desktop is doing something completely no sweat with the transfer rates that you need. You've got your USB thing streaming, camera streaming. You've got your USB storage going, and it's completely not breaking up a sweat. You put it onto your little embedded board, and suddenly you've got frames dropped all over the place. You're not able to keep up with your data rate and writing. you can really get in trouble with this one. And again, this is definitely not a universal problem. I don't think you're ever going to see this on, say, that Minnow board Max that we were hearing about this morning. But especially as you go towards the low power side rather than the CPU horsepower side, you can have this transfer speed. Now, also the really, really cheap can get in here too, because even if you have low power, a good DMA controller can save you. But suppose you don't have a decent DMA controller, or suppose the vendor gave you a cruddy driver that doesn't even, maybe it doesn't even enable DMA, then you're really hosed trying to do PIO USB on a USB 2 speed stream. Yeah. So, and the last category that I've run into is just not really a category I can define. I'll give you an example. This is a real-world example that a couple people in this room will be familiar with. Suppose you have a specialty USB printer. You have it hooked up to a port on your embedded device, and the application is such that somebody turns off power on your embedded device by yanking the power cord. That is not actually that uncommon, right? This isn't a real computer. This is embedded. It's an appliance, so people turn off the power any way they feel like it. Nobody expects to have to do a safe shutdown like on a PC. So here you go. You just done that. You turned it off. Your printer is hooked up. You turn the power back on, and you can't get the printer to talk to you again without cycling the printer's power. What the hey? So it's this one. I think I'll get back to a little bit in the really high-end specialty printer. It was just going wacky. And of course, this never came up in a desktop situation because people don't go around, just pulling the power plug in their PCs. And it probably wouldn't happen anyways because it was something about this particular USB controller that upset it. Upset the printer. Okay, so since this one is really pretty common, let's just discuss this one as its own topic. Suppose you do have one of those typical embedded boards that don't provide your expected 500 milliamps. What do? The obvious answer is go for the external powered target. If you're just getting a hard drive, get one with the external power. You don't need one of those cutesy little, portable dinghies that you put in your laptop bag. Get a real case that has this external power supply. Or, if you're lucky enough to have one of those nice embedded USB controllers that actually does speak the USB hub language, go ahead and use your powered USB hub. Lots of people do that with Raspberry Pis, for instance. They support hubs. And it's a good thing because people have made a ton of usage of being able to hook things up through their hubs. You have your wireless and your keyboards and your mouse and, even your USB video, be powered through your hub. And if neither of those apply,
So a question on the host controller has a power controller in it or a power regulator in it, or is it just power thrust through the connector?
It comes from the embedded board. It'll usually be a regulator that's shared by other stuff on the board. But it might be just if the board is mostly 3 volt, it might have a special boost just for the voltage boost to provide the USB 5.
But if it's just thrust through, in theory, you could just put a bigger power supply on it.
Except the regulators don't always accept it. Okay, so if neither of those apply, and you've got some special purpose, super duper, I can't find an alternative USB target, then you're kind of up the creek. Try a little harder to find an alternate. You'll have to either do rethink your host board choice. You'll have to rethink your special unique target choice.
Could you not just light them in the power cables? At least not recommended.
Yeah.
I mean, magic smoke comes out of. Well, I mean, if you do a 5-volt and like make sure you have from a lamp. If the current starts flowing in the other direction, then it won't.
Well, yeah. If it's not OTG, then you might be able to get away with that.
Then always the red wire.
Yeah.
Okay. No, it's not only that. Usually when you shut down the device, pulling out the plug, if there is a capacitor sitting on the other side, you have to make sure you discharge it before, otherwise the current starts flowing backwards. And a lot of things start.
I don't know if you were here for the earlier talk, but they were talking about how with the early version of the Galileo, you could blow up the power by getting the. So not being the hardware hacker, I'm the.
In the parallel Ethernet community, there's a common component that's just a power injector. Does anybody make a commercial power injector for USB?
No, they expect you to use powered USB hubs.
No, but the hub requires the hub protocol.
Yes.
Right. So does anybody make one that's not a hub?
I've never seen one. That doesn't mean it doesn't exist.
That's the same issue. Yeah. Okay. Just wanted.
Okay. Okay. So let's suppose you're starting a new project and you know that USB is going to be a part of it. There should be a very early discovery phase where you start looking for trouble. What do we got?
My mom told me never to do that.
Your mom didn't play Munchkin. So, first step. This is I'm sure that Steve has been wanting to talk about this one for a couple of slides now. That is, you need to understand your USB system requirements in order to know where the trouble may come from. Are you going to have multiple targets on the bus? Are you going to be having multiple speeds at the same time? Are you going to need a high throughput? Are you going to have targets that are coming and going with the hot plugging? And one that's actually can be particularly tricky in practice. Do you need to be low power conscious enough that you're going to have to be suspending and waking your device? Because that is a real opportunity for things to go haywire just once in a while. Those of us who've been using Linux laptops for a long time can probably remember that there have been times when you have these little glitches that happen, say 1 in 200 boots or whatever. Have fun trying to track that down. So, the big lesson from the field is that you want to validate your needed features early. And the validation can be a combination of researching to see what other people have done with your USB host. Like, say you're on a common platform. Say you're on a Beaglebone. Say you're on a Minnow board. Say you're on a Raspberry Pi. It's pretty well documented what does and does not work on those common platforms. If other people are able to do something, are able to use hubs, are able to use, multiple targets, hot plug, and so forth, then it's a pretty good bet that you'll eventually be able to figure out how to do it too. If it comes down to using the right kernel or, the right hub or whatever. Once they've proved it's doable, then it's no longer a big risk. And maybe you're lucky enough to actually use a platform on this new project that you have personal experience with. Well, certainly your personal experience also applies. Like if you've been able to mix and match USB 1s and 2s in the past, you should expect to still be able to on your next project. Now, lacking those things, say you're using a newer platform that hasn't more bleeding edge, that hasn't existed for a long time, then you're really going to need to focus on the stress testing. Get your hands on an eval board as soon as you possibly can. Do not wait until your hardware engineer has an early spin of your custom board. Use the eval board that they were using for a reference design for their hardware spin. Start doing the tests that apply to it. Like if you know that you're going to be hot plugging, then do your hot plug and see if it gets any issues with using the vendor supplied kernels and the vendor supplied hardware, reference design and so forth. You can do your throughput tests to get a decent speed. Even if your final chip is going to be running at a different clock, you can get a decent idea and then just kind of adjust with the based on the relative clock speeds. Okay. Yeah.
I'm just curious, if you have the same switch controller Userspace chip on multiple different boards, can you be confident that it's going to behave the same, assuming there's enough current for the throughput?
Assuming no hardware glitches, yes.
Right.
Yeah. Yeah. But at least it's been demonstrated that it can be done. And when you take it on the board that worked, and then you show your hardware designer, look, this is what it's doing now. At least you have, a control to compare to. So.
But if you have it on ARM and you have it on x86, I mean, you're talking about the minnow.
It needs to be the exact same chip, not just well, it works on my Beagle board, so it ought to work on my Beaglebone. The CPUs, potentially they are different CPUs, so you could have a funky little glitch that's on one of them and not on the other. So even from the same company.
It's guaranteed on those two boards.
Okay. Okay, suppose that you are unlucky and you did your due diligence and did all your tests and you found something weird. Well, you have a couple of ways to collect data. The obvious first one is to turn to software. USB drivers have some decent debugging, but you'll usually need to turn it on in the kernel yourself. It can be rather verbose, so on purpose, your vendor-supplied kernel config is not going to have the debugging turned on, so you'll have to go turn it on yourself.
You may actually rebuild the kernel with some options, but some just pass the debug elements to it on the.
Well, it depends how the vendor one was built. But usually it will be just plain compiled out. So you're likely to have to go build the kernel with your custom config.
If you're debugging a glitch, turning on that debugging may change everything.
Yes, it may. Absolutely. Absolutely.
Debugging could actually make the problem go away.
It can.
Ship it with debugging enabled. Your refrigerator won't know the difference.
So another really fun tool, you can go ahead and turn on the driver debugging for a while, and learn what you can from it. And then due to the performance tweaking, you probably should turn it back off and instead turn on the USB mon, which is basically the USB version for TCP dump. And you can capture your traffic. Well, it's not really, USB mon is the kernel driver, so that would really be like that that special socket that you compile into the kernel that lets you do TCP dump. But once you turn on USBmon in the kernel, then you can use Wireshark to sniff it as if it were network traffic. And you'll see all the ins and the outs, and you'll remember who's the dictator and who's the minion. Now, the USBmon traffic only goes so far because you are trusting what your drivers are telling you. Usually the USB core stuff, the low level stuff, it will usually give you an accurate representation of what's going on, but it's not as complete as you can get with hardware. For hardware data collection, I don't actually know about the open hardware choices. Maybe somebody could contribute that. But I do know that Total Phase is one of those commercial companies that at least supports Linux reliably. In fact, I turned them up on the Linux USB drivers. They're rather neglected web page that talks about USB stuff, but they recommended Total Phase there, and I've found that to be a good recommendation. We're actually using that with 2 different clients, and it's, for one thing, past the USBmon. Suppose you had a bug in your drivers that was actually scrambling your data before the USBmon gets to it. You know, that is possible. Anything is possible in software, right? So this is a third party. There's no way that anything naughty that your kernel is doing could affect the accuracy of the data controlled by your outside hardware tool. And the other thing is that it also shows you stuff about the like the enumeration stage and some of the stuff that is not actually data, like the chirp keys and stuff like that, where it's trying to negotiate the data speed. That's not going to show up in your USBmon traffic, lower level. And sometimes that's actually important. So I'll go ahead and finish the little case study that I mentioned about this Bizarro printer, where it would go catatonic if you turned off the USB host while it was talking to it. It turned out that this was actually a pretty deep hardware problem that we never found, and we ended up, I even used the Total Phase to sniff it, and it was, everything was proper from the host side when it was coming up the second time and the printer refused to finish enumeration. Everything was perfect. Basically, there was some low-level, electrical level problem that was making the firmware inside the printer unhappy, such that it was stateful, and the next time you tried to do an enumeration, wherever you tried to do it, it would just goof up. And there was basically nothing you could do from the driver at that point. So this leads into our next question is, okay, so you've characterized it. What do you do now? So if you're lucky, you've just found something that was a driver bug. Like, for instance, some of those, I'm getting terrible transfer speeds problems turn out to be driver problems where the vendor released the drivers with DMA disabled because they were still working on the glitches with their DMA engine. So once that gets solved, you can update to a newer kernel and wonderful things happen instead of the frustrating stuff that you were going through before. Now, the second best thing that you can hope for is that there's driver workarounds. Sometimes if you have a really special case for your USB, you can go in and disable some of the other features, the kind of, just hacking stuff that would never be allowed upstream. But if you need to get your product out, in a couple months, you may go for it now until the real fixes come out in the future. But if there's other things where you just cannot address it by software, and that's when you need the hardware fix. You end up hoping that somebody was smart enough on the hardware team to allow you to have a PCI bus and get in a separate USB controller. The PCI controllers tend to be much less bizarre than the ones that they tried to smash into the SoC. It's their whole purpose in life, so they try to do a pretty standard job at it. And that is actually how the case of the frustrating printer got solved. Was, well, don't plug it into that port. Plug it into this other port over here. Voila, on a different controller. Because, what driver workaround can you do when the thing that makes the target unhappy is electrical noise or something that's going on as you're dying from the power outage, right? The managers always want a software fix. How can you do that? Yeah. Yeah, but the problem was it was one of these super specialty ones that the product had to work with. Yeah. Okay, so we've talked about all the ways in which embedded USB can be quirky. Now let's get to some of the fun stuff instead of the frustrating stuff. One of the fun things you can do with the embedded USB that you would be hard pressed to do with your beefy desktop machine is be the target. So suppose you have your USB host and you have your you have your USB Ethernet hooked up to it, and then over some network cable there's some remote Ethernet hooked up to some remote peer. Well, Linux can do this too. You can be the Ethernet. But the trick to it is you don't just get to be the Ethernet when you're a Linux smart target. You get to be the Ethernet and actually be the remote Ethernet and the remote peer to boot, because you're actually sending the stuff that you want to over your network into that USB port. So this can be kind of fun, and this is how all you people with the the Android devices, if you like to do the USB Ethernet gadget, this is essentially you. You're being the Ethernet and you're being this remote peer too, all at the same time. And it doesn't stop at Ethernet. You can have USB serials. Your USB host thinks you're communicating with some remote device over a serial port. Again, there's a gadget that lets Linux be the serial. And, oh, by the way, it plays the remote peer as well. Here's the next fun feature. You can have on-the-go ports. Like, for instance, this is really common on anything that any of the CPUs that might be intended for mobile usage. They will generally provide you an on-the-go port. And on-the-go just means that your USB controller has a split personality. At any point you can decide, do I want to be the host or do I want to be the target? So the trick is the direction of the cable that you plug into it picks which one you start up as. You have these little things marketed as on-the-go cables. That means that you use them for your phones usually, right? And You have to plug the right side of your AB cable into your embedded port to decide whether it's going to act as host or target. If you want it to be host right now, you plug the A side in. You have these little connectors, they call them the AB connectors, so that either side can plug in if you want to. So you could, if you're plugging it up to, say, a keyboard, then you plug the A side into your phone. If you're hooking it up to your computer, you would plug the B side into your, okay, a B side, a cable that has a B side for your micro. Now we have the little twist. Remember how I told you that the USB hosts are just complete dictators and they never listen to their minions, they just command them. Okay, you, report. Now you get a command. Well, the host negotiation protocol is part of the on-the-go specification for USB, and it works between two devices that have the split personality. So let's say you have your cable and you hook it up, and device 1 over here gets to be the host first, and device 2 gets to be the target first. Well, it's like you have a couple of kids who are playing dictator and minion, and then the one who's playing the minion after a while says, you know, I'm tired of being the minion, I want to be the dictator. And then they can negotiate to swap roles without physically unplugging the cable and turning around the cable. Now, this seems like a really cool thing, but technically I haven't actually found a lot of uses for it in the real world. A lot of times you just decide which way to plug your cable in, and that is the direction that that you'll be using it for a while. I haven't seen a lot of this. You'll find test pages online that tell you how to do this role swapping. It seems to be kind of board specific though. It's like, well, if you go poke this over in the SysFS area, then you can trigger a role swap. I haven't found any standard ways to do it yet. Something to remember, if you are doing this OTG stuff between two devices that both talk on the go, the one that the cable still matters, because the one that starts out as host is still supposed to be powering the VBus. Now, it may not be giving much power. It doesn't have to provide any 500 milliamps, like I said before. I think it's supposed to be 100 milliamps. 100. So if you have one that's really low battery and you wish the other one would be giving it a little bit of trickle charge, then pay attention to which way you hook up the cable. Because the host negotiation protocol just determines who gets to act as host data-wise. They decided not to do some complicated thing where the 5 volts turns around power, turns direction around. Okay, so a lot of this stuff was kind of generic about embedded USB from the system perspective. Let's talk about the actual Linux side. What are the drivers that you're going to be using if you design a system that has USB in it? Well, at the very bottom of the stack, you have your host controller drivers, which actually might be the similar ones to what you use on the desktop, namely the OHCI, EHCI, and in rare cases, XHCI if you're doing USB 3. But a lot of times you end up with this other thing called MUSB, where the M stands for mentor, because it's one of those IP cores that Mentor Graphics once upon a time designed, and they've licensed out to a whole bunch of different SoC chip makers. There's been a lot of forking going on, so you can't necessarily depend on the things that work with one MUSB to work on the other. But in fact, they're some of the ones that were responsible for that annoying non-hub supporting trick. But anyways, if you've got an MUB, then you'll just have to cope with it. Some of the newer ones that are actually seem pretty decent. Oops, wrong way. MUSB, yeah. Yeah. TI is one of the ones who licensed it. Okay, on top of that.
The Beagle board has an API in addition to the MUSB.
Yeah.
Those would be probably the worst installers. They're quirks. That's with all of them. I mean, the MUSB stuff, there's lots of good workarounds that still work pretty well, but not always as good.
Okay, USB core is kind of a glue layer that they, as a system designer, just at the person responsible for the software, you probably don't have to worry about this too much because usually the release kernels have the USB core behaving pretty well. I've mostly found problems in the glitchy hardware or higher level drivers. So above the USB core is what people probably usually think of as USB drivers. And these are the ones that tell the USB host controller how to talk to different kinds of targets. And I have this split up into the standard and custom ones because there's the standard ones like USB storage, USB net, which go with defined USB classes on how those protocols are supposed to go. There's actual standards on what a USB Ethernet is supposed to do and what a USB storage device is supposed to do. But people are free to write their own protocols on USB. There's all kinds of there's all kinds of custom stuff that Linux is a great way to take advantage of because they have this generic layer. Used to be a file system that you would mount called USBFS. In modern times, it tends to be through device files, but still, it gives you the low-level access you need to do basically anything you want that is possible with USB. Finally, on top of that, you have your user space. If you're working with one of the standard drivers, then you may not be running a USB app at all. You might just be running your network apps and happen to talk to a USB 0 device, right? You don't really care at the app layer in that case. You could be, writing to file systems, and your user space does not care that one of them happens to be a USB stick. Whereas you tend to care a lot more when you're dealing with those custom protocols, because on top of the low-level generic access, you tend to use the library called libUSB that is a nice wrapper for your custom stuff. And I've seen things like reflashing utilities that end up getting built over libUSB. There's no standard USB class that says how one must flash a new firmware onto your FTDI part or whatever. There is? How come nobody goes with it?
Nobody uses it, but there is a USB class for flashing firmware.
Well, that's frustrating then.
Yeah, but hardly anybody.
I've never seen it used.
Yeah, they don't. I don't know. Part of the reason that the flash restriction is cheaper, at least for the hardware that I'm using, UBSB. It's the USB tool. Device firmware upgrade.
Okay.
It's on a lot of popular open platforms, but it's a very minimal set class.
Okay.
And it's a little bit complicated to implement versus just using something like libUSB and just say, okay, this is the functionality I
Oh, not mine. Thank you, though. Does anybody have any other good examples of their libUSB custom fun programs? I know Greg KH has done some funky stuff with the libUSB before. But
LibUSD only ever works for me on Linux code, so works great.
wait, what else would you use it on?
For people that you're trying to convert away from these other platforms to Linux, then you want to give them a flashing tool
Yeah.
such that they can program to run Linux.
Oh, okay.
Yeah.
Well, it sounds like an interesting use case, but it's not one I've ever dealt with. Yes. Yes. That's one of the flashing utils I was thinking of. Okay, so now we're going to go upside down because it's in kind of a nice symmetry, but this is actually the lowest level. From the target perspective, the analogy to the host controller drivers is the peripheral controller drivers, and I've found that this tends to be a lot more vendor specific. There's the Intel one, there's the Atmel one, there's the TI one. They haven't standardized as much as the EHCI, where basically it used to be Intel's vendor-specific one, but other people adopted it. So now things are happy because you have a pretty standard interface. We're not there yet with the target equivalent. Then you have a gadget core, which is the common framework again in the kernel. And this one actually has some nifty features in it. The gadget core includes this composite gadget stuff, which is basically build your own target where you have multifunction devices and you can reconfigure them dynamically, and there's actually some pretty interesting stuff there. And I think if you want to hear more about it, you should probably talk to Matt Porter, who's coming up soon, because he actually wrote a library, Userspace library, to make it more convenient. So then you have, again, your classish drivers. One side does the storage for the host, the other side does USB storage from the target side, and all these have the G underscore to kind of give people the hint that they're running the target version instead of the normal host version. So you have G storage counterpart to USB storage, G ether counter to USB net, you have a G serial, and so forth and so forth. But again, since sometimes you're not going to be able to fit well into one of the predefined gadget classes, there are the kernel provides the custom facilities for making protocols. Once upon a time, there was Gadget FS, and that actually lasted for many years. In recent times, Gadget FS has been demoted into we're trying to make this deprecated directory, and if you're doing new designs, you're really supposed to use Function FS. I'm working on a project that started out with an older kernel, and I found out that Gadget FS actually had bit rotted a bit and actually had to submit a patch to get it to even load and unload as a module decently. So I would highly recommend using Function FS if you can. But on the other hand, a colleague said that there were some real details about using alternate interfaces where they couldn't quite figure out how to do it yet with Function FS. So you might have a little bit of fun if you're trying to convert some old Gadget FS code into using the Function FS system instead. So finally, on top of the gadget drivers, you will normally have the Userspace level. Like, for instance, the network app that is talking to your interface created by G-Ether that is basically acting as the peer computer to your USB host. You also might have a Userspace that was talking on the other end of G-Serial, talking G-Serial to your host computer. Over on the custom side, I was kind of looking for a counterpart to libUSB for doing the endpoint manipulations and kind of a nice wrapper to clean things up, provide a consistent interface. I found one thing on GitHub that was called gadget, but I haven't actually used it yet. So if you something to look at, but I can't give it a huge recommendation because basically that's all I did. I looked and saw it was there. I haven't used it yet. On the other hand, if you're trying to make one of those nifty multifunction gadget drivers, I just found out today. For instance, this is pretty common on tablets, where you have the tablet, you want to do your USB net at the same time as you're doing your ADB, and maybe you're trying to do something else at the same time, like another custom function that you invented maybe. There is a library that will help you out with that, and that is called libusbg on github.com. And that helps you do the dynamic configuration to basically assemble your target. Say, I want some of this, I want some of that, and I want some of that. So for the custom side, you can find both MPP and ADB examples implemented on top of FunctionFS. That's actually probably a good thing to look at if you're interested in implementing your own protocol using FunctionFS, since there really isn't a large amount of high-quality documentation for this part of the Linux space. Most of the write your own custom user space guides seem to be for the host side. So now that we've talked about the standard drivers that you would definitely want to be picking and choosing from for your final product, let's take a little look at the development and test drivers. I've really found only two places that talk about this in any great detail. One is the Linux USB site, which has a lot of really good info, but is a little bit on the dated side. And the other is your good old-fashioned Linux documentation directory. Those are pretty much the best sources of information I found for this topic. So, is it gone again? I can't find it. Let me put it on. Oh, we're done. Should I repeat anything? Was it too quiet? Okay, thanks. Okay, so basically I just said that my two best sources of information for what to do with respect to development and test of drivers are the linuxusb.org site and your friendly neighborhood Linux documentation directory. There's not too many great tutorials out there on this topic yet. So here we have again this top part is the host side of the system, and the blue part is the target side. We have one really interesting driver called dummy HCD that actually crosses both sides. In other words, it emulates both the host controller hardware and the host controller driver, and the peripheral controller driver, and the target controller hardware. So the interfaces that it exposes, it lets you talk to both. You can, it's like kind of like a local loopback where you can talk in one side on the host, and on the other side you can talk target. So this can be a really great thing for testing your higher level drivers. Like say you're writing something that has libUSB and custom protocol on the one side, and you have functionFS and your custom Userspace code on the other side. You can actually work on this on your big beefy desktop Linux machine instead of having to go out and do the initial driver development with your target hooked up. So I think that could come in handy. Also, if you're trying to do work on, say you're debugging one of the class drivers for some reason, dummy HCD could be your friend. Now, the driver that gets a lot of space in discussion on the linuxusb.org site is the USB test one. This one is good for testing your hardware. What you have is a little system for stress testing. It'll do different types of. It actually implements a number of different built-in tests that you can select among. It'll do different types of traffic, and it's driving it from it's a host side driver. So you could use your USB test, and you could talk through, say, a real hardware controller and talk to anything that implements they call it the gadget 0 protocol. And that's basically the peer that USB test expects to talk to. And you would use, in the user space, you would generally use the test USB program. I know it's aptly named. These things are so memorable. You have your USB test talking with your test USB to drive it. And they have an example, test.sh, that you can also get at the Linux USB site. And if you're actually working on one of those platforms where you're not totally confident of the hardware yet, this is a good way to test the long-term looking for data corruption type bugs. There's certain types of things that it's not going to test, like it's not going to test your connect disconnect problems. It's not even going to test problems that you run into with using multiple endpoints in parallel, which was a little disappointing because I had a specific thing I wanted to test a while back, and it didn't do that. But it does turn up a good category of bugs, and so it's worth looking into if you're trying to test your not hardware that you're not totally comfortable with yet. In addition to Gadget 0, there's actually other counterparts on the target side that you can run that implement the same protocol. In the old days, there was gadgetFS and USB.C, which is something that's hosted again on linuxusb.org. But if you've decided to come into the modern era, and you're using functionFS, then you can have your USB test counterpart actually in the kernel tree over in the area that has the other user space tools, like perf and so forth. There's that little directory that has non-kernel code. Look there and you'll find FFS test.c, and that is meant to be run with the USB test driver. On a separate note, which is not really so much testing as driver development, suppose you're trying to come up with your own protocol driver and for some reason you decide to do it kernel space instead of using USBFS plus libUSB, there is a nice, really simple example called USB skeleton that the developers tend to keep up to dated and working. And all it does is a couple of bulk endpoints that you can access from Userspace. And there's not really a lot of points, for a production system. It's pretty much more for learning how to do one of your own drivers that would do something more interesting. So if there's any questions that people haven't already asked, especially ones that I might be able to answer, go for it.
Well, before we start the questions, give her a round of applause. If you have a question, let me hand you the microphone so it can be nice and loud here.
Somebody has dropped one of these cards and may be looking for it.
All right.
Before they leave.
Any other questions? So I'll try to do it without the mic, maybe, or it's streaming live. So.
Oh, okay. So what's your experience been with USB Mon and its effect on the system's performance and activity? In other words, does it tend to also submerge problems because of timing, or does it work pretty well for you?
It's been worthwhile. If I do something that really is timing sensitive, I would go to the hardware, but it's not a high overhead. So you'd be pretty unlucky if it made your bug disappear.
Hi, this is a little bit about a fairly general how USB works question that, like a few years ago, I noticed that there were changes in the implementation on how to verify the integrity of data when it gets transferred across USB. In fact, even at one point, I remember one Windows system I was looking at actually was implementing TCP/IP over the USB connection. I was wondering if you knew in any way. It's a little maybe a little off topic from what you're talking about, but maybe you might know how does USB verify the data integrity as it's being transferred?
There are checksums, but they're optional, and not all protocols use it as part of the low-level USB. So I think it depends on the protocol.
How about the USB video class? Do you find that there's support for that in the embedded space?
There is. There is a gadget for the UVC cameras.
So if I learned anything, that would be G_vid or something like that?
I think it's G_UVC.
Thank you.
So I've got some probably a bit off topic. Do you know anything about the USB hack and anything we could, or any tools that have been made to intercept that kind of stuff?
You mean the recent? Are you talking about the Mac one?
I don't know if it was Mac. When I read about it, they were talking about it was a basic flaw in USB, which you could use to hijack for, effectively.
I saw one that where it was basically. You could do this with a little embedded Linux device. What you would do is you implement the USB storage because you make it up to look like a little stick, and then you also stick in a HID device, HID, meaning you're also pretending to be the keyboard, and it looks like a stick, but it's secretly sending keyboard presses into your computer as well. Is that the kind of thing that you're talking about? And then, there's not very much that you can do about it because from the USB host side, it has no clue that that the user didn't intentionally plug in a new USB keyboard.
Maybe, I don't remember the name.
Isn't there a UDEV rules approach to shut that down? I don't know.
Well,
UDEV rules system this vendor and this device ID and its storage.
Yes.
And never,
If you're
never
go-
found a device
that's a Linux solution
Yeah.
though. That's not a Mac solution. And it was Mac computers that were being attacked when
Good.
I heard about it.
Use Linux.
Because yeah, if you're trying to be secure in a secure device, you probably don't have USB. But if you did, then you would certainly lock it down to specific vendors and stuff that you trusted. Yeah, but if you have the vendor, yeah, it can just tell you what vendor it is. But people who are, it depends, you know. Then it would have to be a targeted at your site kind of a thing. They would have to know that you were allowing this brand of SanDisk, and they wouldn't allow it to this SanDisk to turn up as a keyboard, right? Yeah. Yes, I'm sure that could be done. But then they would just have to figure out what mice you use and make it look like your mouse.
So he pointed out it was called bad USB,
Mhm.
and it was a you could utilize it to overwrite the firmware. So, and then from there you could do a whole lot more.
That was still a Mac one though, wasn't it?
I don't think it was.
Open
Was it just
firmware.
Mac? I thought
Open
it was Mac
firmware.
was more phone.
Particular implementation of the USB call chip, which unfortunately we don't know how many devices are out there with that particular code because the company
Mhm.
licensed to any Chinese
Yeah.
manufacturer.
Okay.
Well, I can speak from personal experience. I've worked with a couple of companies that do top secret work, and they spent tens of thousands of dollars a year on epoxy glue for USB ports. Every laptop that they purchased was USB ports were filled with epoxy.
Yeah.
Oh, sorry. Any other questions? We got a couple here in the back.
So earlier you said there were limited tutorials on this subject.
Especially on the gadget side of custom protocols, you will tend to find a number that talk about how to use libUSB to write your own nifty host side drivers for custom whatevers you get off the internet. But not so much on, well, I want to be one of these custom whatevers that you then put on eBay or whatever.
So where would you go if you wanted to get started with USB programming or driver programming in general?
The host side host side Userspace is a good place to start. And Greg Crow Hartman has posted some nice tutorials on that. Don't start with the target side. Do that later.
All right. Thank you.
So on the gadget side, I've been down that road. You can get for Function FS, you can go to Danx's site, right, where the U-boot tree is hosted. On their Git tree, there's a PTP gadget driver, right? So when Function FS came in, the kernel was being discussed. That was one of the reference protocols that was implemented. It's a pretty good implementation of a Function FS based gadget. I've used that for some of my projects as a guideline and so forth.
Oh, that's actually a great one. Thank you.
It's fairly complex.
It is, but it's what I used when we were looking into converting Gadget FS to Function FS because they made that transition, and you can get the Git and see what they did during it.
Yeah, you can look at both versions exactly. So it's the ptp-gadget.git repository on
but
the
I still don't recommend that for starting out in drivers.
Yeah, there's no good tutorial out there. It's all tribal knowledge.
Yeah.
Well, we're going.
I put up a couple of them, like the MTP and the ADB also went Function FS implementations. But again, you'd just be learning by looking at the code and not a tutorial.
All right, so we're going to go ahead and close this one out. We've got a kernel debugging question and answer session coming up with Matt Porter and myself. So in 10 minutes. But before you go, just one last thing. In my personal dictionary, USB stands for unlimited supply of bugs. Thank you, everyone. Give her a hand.
I will. I'll have to remember that. I really will. Unlimited supply bugs.